Many times everyone has thought about how huge our universe is, whose age and size lie beyond human comprehension. Our planetary home with humans on board is lost somewhere in the boundless space. They, in turn, have developed quite well and recently acquired interesting and noteworthy theories of the origin and structure of the universe. The Big Bang theory may have become almost as widely accepted a cosmological model as the Earth's rotation around the Sun. According to the theory, about 14 billion years ago, spontaneous oscillations in the absolute void gave rise to the universe, something comparable in size to a particle, which in a fraction of a second increased to unimaginable dimensions. But there are many gaps in this theory. That's why many physicists, scientists, and even just science fictionists put forward more and more new assumptions. Here are some of them. The theory of the stationary universe. The universe has always existed in an unchanging state. Supporters of the stationary universe theory, popular in the 50s and 60s, believed so. What about the apparent expansion of the universe? Proponents of this theory believed that the universe may be expanding, but that it remains the same, with matter constantly emerging from nothing. Cyclic model. This theory does not deny the Big Bang theory, but states that there were many consecutive Big Bangs. Between the two loud explosions, there was a loud roar, so the universe expanded to its limit and then contracted. A big bounce. This interesting alternative theory of the Big Bang suggests that another universe existed before our universe. Thus, while the birth of the universe, namely the Big Bang, was seen as a unique phenomenon, in this theory it is only one link in the chain of reactions by which the universe continuously reproduces itself. String theory and M theory. It also has many branches, but the general idea is that the universe can constantly reproduce itself. Some believe that our universe came about as a result of quantum fluctuations in the previous universe, so it is possible that at some point our universe may also undergo new fluctuations for some reason, and a new and different universe may yet appear. For example, did you wear pink tights today? If so, it may have caused another universe that your next doppelganger didn't for ethical reasons. While we're talking about illusions, there's another theory that claims we're all inside a hologram created by the universe itself. According to this theory, when we look at the night sky, we see a wall covered with an image of all the galaxies and stars. Which theory do you think is reasonable? Let's figure it out together. And for starters, let's go back 500 years to when the Renaissance scientist Nicholas Copernicus stopped considering the Earth as the center of the solar system. People gained a new understanding of our planet. His idea became one of the biggest scientific discoveries of the last few hundred years, and an important pointer on our way to understand the inner structure of the cosmos and the nature of the real world. We know that our planet orbits a medium-sized star that is one of about 200 billion stars in the vast vortex of matter that makes up the Milky Way galaxy. Our galaxy is one of an estimated several hundred billion such structures in the observable universe. By any puny human standards, the universe is a vast amount of matter and a gigantic space. Imagine that you have gone to one of the distant galaxies and are about to send a monkey to your loved ones on planet Earth, thus the third planet from the Sun. Next is the solar system, in Orion's arm, next door to the Milky Way. Then you will show the location of the Milky Way in the local group of galaxies. The cluster of more than 50 nearby galaxies spans about 7 million light-years. The local group in turn is located on the edge of the Virgo cluster, which contains more than 1,000 galaxies at a distance of 50 million light-years from us. And this cluster itself is only a small part of the local supercluster of galaxies, which unites hundreds of similar clusters located in a space of 100 million light-years. And superclusters are one of the largest structures in the known universe. They consist of groups similar to our local cluster containing tens of galaxies, as well as massive clusters containing hundreds of galaxies. All these clusters are connected and the boundaries are not easy to define. Let's hope that our monkey will not see other civilizations on its way to Earth. Moreover, the whole system expands, pulling the galaxies away from each other, just as the points on the surface of a balloon move away from each other when it is inflated. It is of such unimaginable size that a catalog of cosmic currents has been created, containing a wealth of data that sheds light on the dynamics of one. 8,000 galaxies located within 130 million light-years of the Milky Way, and later up to 8,000 galaxies within a sphere with a radius of 650 million light-years. As the catalog grew, they suddenly discovered a picture hidden in the mass of data, the outlines of a new, previously unseen cosmic structure. A cluster of galaxies spanning more than 400 million light-years is moving toward a small region of gravity like streams of water, converging to the lowest point on a landscape. If it were not for some mechanism in the universe, these galaxies would eventually merge into one compact structure, connected by gravitational attraction. This entire giant collection of galaxies is called the Laniakea supergroup, which means melting brain in Hawaiian. Okay, just kidding. Wide skies. In honor of the first Polynesians who navigated the stars to explore the vast expanses of the Pacific Ocean by boat. A ruler is not just another line in our space address. Its diameter is 500 million light-years. It consists of about 100,000 galaxies with a total mass of about 100 million billion solar masses. Superclusters also include the Virgo cluster and the Great Tractor, or rather, the Attractor. Inside the Laniakea supergroup, the motion of galaxies is like water flowing down a valley. The large attractor, in turn, acts as a large, flat-bottomed gravitational valley with a Laniakea supercollapse scope. By studying the architecture and dynamics of this gigantic structure, we can learn more about the past and future of the universe. Mapping the galaxies that inhabit it and studying their behavior can help to better understand how the mechanism that controls the growth and motion of galaxies is formed, and will also reveal new details about the nature of dark matter, the invisible substance that makes up about 80% of the matter in the universe. Of course, on the scale of the universe, everything is relative. It may seem to us that the world we live in is simply unimaginably huge. But this is only a small part of the even larger structure of the solar system, which in turn looks like a tiny grain of sand against the background of our own Milky Way galaxy. These are such unimaginable distances that, for comparison, it is the same as spraying a pile of sand over a football field. And so you choose only one particle to be the solar system. Humanity makes more and more scientific discoveries. It is like a moment of enlightenment, a push that overturns our established view of the world. For example, it happened when we learned that the Earth is round, not flat, that our planet revolves around the Sun, not the other way around, that there are other galaxies in the universe. And this process continues. With each step our knowledge expands, and another scientific breakthrough leaves behind a number of new questions, including the question of the origin of the universe. Have you found your answer? There is a theory that our universe is infinite. But just because we can't see what's beyond the horizon doesn't mean it's infinite. And if it is not infinite, then what lies beyond it? Let's try to understand everything. First, we need to understand what defines the cosmic horizon, and how far into the universe we can see. It would be naive to think that astronomers can look at any distance they want, just give them a bigger telescope. These considerations do not take into account the finite speed of light and the finite age of the universe. What does the speed of light at 300,000 kilometers per second have to do with our ability to see deep into space? Determinant. The point is that looking far into space also means looking far into the past. On a clear summer night, you can see the bright star Deneb in the Cygnus constellation. A huge bright star is easily visible to the naked eye, despite the distance of about 2,600 light-years. This means that the light we see today was emitted 2,600 years ago when the Spartans were still digging the same pit. This means that we see this star not as it is now, but as it was more than 2.5 millennia ago. We look to the past, and in modern times, the star may no longer exist. Now let's turn our attention to the galaxy NGC 474. The distance to it is about 100 million light-years. The light we receive today was emitted when dinosaurs still roamed the Earth. Or maybe none at all. By observing NGC 474, astronomers are looking back 100 million years. It is not for nothing that telescopes are sometimes called time machines. But why these examples? Perhaps seeing the past has the advantage of allowing us to study the evolution of the universe. Want to know what the universe looked like about 8 billion years ago? On Kelta, the telescope is located in a galaxy 8 billion light-years away, or rather a galaxy so far away that their light traveling through expanding space takes 8 billion years to reach us. Of course, there is also a drawback, a fundamental limit to our ability to look into space. When our universe was born 13.8 billion years ago, this is the maximum time light could have spent traveling. We simply cannot see the past more than 13.8 billion light-years away. The universe is vast, but we can only observe a relatively small part of it, a spherical region 13.8 billion light-years in radius centered in the Milky Way. We call this region the observable universe. The surface of this sphere is our cosmic horizon. Yes, that's right. Any place in the universe has its own cosmic horizon. The following example will help us understand this. Imagine a ship in the ocean. Each ship has its own horizon, the center of which it is, and beyond which the sailors of that ship cannot look. Similarly, each observer in the universe is at the center of a small, personal, observable universe. This means that an alien such as Chewbacca, which is right on our horizon, will not see anything interesting. His immediate environment will look very similar to ours, the oldest stars and mature galaxies, because he lives in the same universe. But we will also be on its horizon. Our alien friend Chewbacca will be looking 13.8 billion years into the past, an era long before the birth of our Milky Way galaxy, let alone the Sun and Earth. And so, finally, we are gradually approaching the so-called post-creation world. The term, coined by British astronomer and writer Marcus Chown, refers to what an observer sees at the very edge of the universe, and what he sees is the pale glow of a monstrous Big Bang. What is beyond the cosmic horizon? The fact is that during the first few 100,000 years of its existence, the universe was filled with turbulent plasma, so dense and hot that light could not pass through it. But when the universe reached 380,000 years old, the density and temperature dropped enough to allow electrically neutral atoms to form. At that time, the entire universe was as hot and blindingly bright as the surface of the sun. So when we look beyond the cosmic horizon, we should see the glow of the Big Bang everywhere we look. And we see it. True, this primary radiation was on its way for 13.8 billion years, minus the negligible 380,000 years. Moreover, the radiation traveled in the ever-expanding universe. As a result, its wavelength was stretched about 1,000 times, and the glow turned into an almost unrecognizable whistle of radio frequencies. This whistle is commonly referred to as the cosmic microwave background radiation, or relic radiation. For the record, the relic radiation is the oldest signal that astronomers can observe. We cannot come close to the birth of the universe. It is difficult for some people to realize that the afterglow of creation can be studied continuously for decades. But to be fair, even dinosaurs with enough gadgets could see it. Of course, the question arises here, was the birth of the universe not an elusive short event? Shouldn't the radiation of that era just fly by? So how do we still manage to observe the afterglow? The explanation also has to do with the extremity of the speed of light. Let's do another thought experiment. Imagine that there is a crowd of thousands in a large city square. Everyone is ordered to synchronize their watches to the nearest second and shout the word caramba exactly at noon. But one detail. The town square is on a planet where the speed of sound is not the usual 330 meters per second, but only 1 meter per second. What happens at noon? You shout the word caramba at the top of your lungs. You can do it. The sound you create travels in all directions. After 1 second, you can no longer hear your own screams. But at 12 o'clock in 1 second, you can hear the friendly commotion of people a meter away. It takes 1 second for the sound to reach you. At 12 o'clock 2 seconds, you can still hear the word caramba, but from people at a distance of 2 meters. Even a minute after dinner, the scream reaches the ears. It comes from people at a distance of 40, 70, 100 meters. But the strange thing is that no one is screaming anymore. At exactly noon, everyone in the square let out a short cry. But you keep hearing this madness called caramba coming from far and wide. If the area is really big, you will hear the caramba for hours and you won't forget it for days. This example helps us understand the following. The town square is a universe. A carambola of universal proportions is a brief burst of relic radiation shortly after the Big Bang. Relic radiation that dropped on the 13th. 8 billion years ago, at our point in space where you are now, long ago dissipated in the universe. But we're still getting weaker signals further and further out into space. It is an echo that is beyond space. Cosmology is an actively developing field of science, full of mysteries and stunning discoveries. We may never fully understand how it all began, but perhaps a record of the primordial gravitational waves created at the time of the Big Bang will allow us to see the birth of the universe in a new light. A black hole is one of the most mysterious phenomena in the universe. It is very difficult to find it with the eye, since this zone does not emit any light, so it is practically invisible. However, in this phenomenon, light rays are bent. That is, if there is a black hole between us and a distant galaxy, the light towards the galaxy will be bent because it must pass through the black hole's gravitational field. The deflection of the rays is called the gravitational glow. This effect also occurs when large collections of mass, such as galaxies or galaxy clusters, are in the way and deflect light from underlying objects. But of course, the possibilities of black holes do not end there. Recently, science has managed to discover a whole arsenal of other various features of these objects. It turns out that not only are they able to travel at near light speed and show signs of true space maniacs, but they also exhibit much more flexible behavior than we've come to expect from them. Today we will talk about the 10 known superpowers of black holes. The first ability, let's call it space tornado. As the name suggests, black holes spin rapidly. The estimated speed of a supermassive black hole is 84% of the speed of light. Let's look at an example. The black hole in the galaxy NGC 1365, located 60 million light-years away, is a strange black hole. Its diameter is 3.2 million kilometers, and its mass is approximately several million solar masses. As it spins, it literally warps not only space but time behind it, creating a fiery vortex of X-rays, gas, and dust that enter its interior. All this matter most likely enters the black hole from one side, which gives it such an incredible speed of rotation. Superpower, friendship. And these are black holes that come together and agree on something. And it looks like it happens a lot more often than we think. The largest galaxies discovered are literally littered with supermassive black holes. They are so huge that the scientific community doubts that their progenitors are single stars. It has long been thought that supermassive black holes can be born in dense star clusters consisting of groups of dying binaries, or groups Yes, black holes can throw Jupiter-sized matter. In general, play snowballs only on a cosmic scale and sometimes in our direction. It's winter, really. Theoretical calculations and computer simulations suggest that near the central black hole of our galaxy, Sagittarius A, there may be a very massive star that comes very close to the hole every 10,000 years, causing the latter to extract stellar material from it. It forms a long jet of luminous substance. Some of this matter is devoured by the hole itself, and other matter is ejected into space. However, some of this matter remains not far enough from the distance hole and is able to coalesce into a ball the size of a planet. But even that is not the most interesting thing. These clumps of matter, in some cases the size of Neptune and sometimes reaching the size of Jupiter, are ejected into galactic space at speeds of up to 32.2 million kilometers per hour. According to the researchers' calculations, as a result of the tidal collapse of the star, about 100 million such bodies will be thrown into space. The fourth superpower of a black hole is to hide the galactic past. This is great skill. Let's find out how it manifests itself. Thus, the ALMA radio telescope complex made it possible to see the torus of a black hole, a cluster of dust and gas that rotates around the mouth of a galactic monster that looks like a cute donut from the outside. The object of study is located at a distance of 47 million light-years from us in the constellation Cetus. Thanks to ALMA's amazing power and sensitivity, we were even able to calculate its width. It is at a distance of about 20 light-years from us. By observing the tori of black holes, researchers can learn more about the galaxy's past. For example, an asymmetric shape of a torus may indicate that a galaxy may have merged with another galaxy at some point in its past history. The fifth superpower is to devour matter, and with incredible speed. And black holes are always insatiable. Billions of light-years away in the direction of the constellation Veronica's Hare is a very bright galaxy called PJ 211. The galaxy owes its brightness to the central black hole, which absorbs matter from space at an incredible speed, 100,000 kilometers per second. The researchers found that the X-ray emission of this galaxy shows a significant redshift, which can be explained by the movement of the matter of this galaxy directly towards the central supermassive black hole at an enormous speed of about 30% of the speed of light. This gas almost never revolves around the black hole, but moves straight towards its center in a straight line, being incredibly close to the black hole's center. And we will move on to introduce the sixth superpower called loneliness. A lonely interstellar wolf named Black Hole likes to wander through space. For a long time it was believed that black holes could occasionally be ejected from their galaxies, and a very serious confirmation of this assumption, as it turns out, is about 8 billion light-years away. This is Quasar 3C186, which has a mass of 1 billion solar masses. It also turns out that Quasar really wants to leave his home cluster of galaxies. According to the researchers' calculations, the Quasar gas cloud is moving at a speed of 7.6 million kilometers per hour. At this speed, for example, you can get from the Earth to the Moon in just 3 minutes. Astronomers believe that this escape is caused by gravitational waves, the product of the merger of two supermassive black holes. As a result of this fusion, they created a powerful shock wave, comparable in strength to the simultaneous explosion of 100 million supernovae, which literally pushed Quasar out of place. As they say, go home, gringo. The seventh superpower is theft. As it turns out, small black holes have learned to steal from their larger relatives. At the moment, 5 black hole merger events and the gravitational waves produced by them have been officially confirmed, but they also identified one thing that stands out among them. We are talking about the merger of 2 black holes, the mass of which, according to forecasts, should have been from 10 to 15 solar masses. In fact, it turned out that the mass of both black holes exceeds 20 masses of the Sun. After analyzing the collected data, he came to the conclusion that both black holes gained weight because they stole food from a much larger black hole, also located nearby in the galactic center. This is because before becoming black holes, these thieves were 2 massive stars. In the course of stellar evolution, they collapsed into black holes and were attracted to the galactic center, where there was already a supermassive black hole absorbing the surrounding gas and dust. The 2 particles managed to steal the candy from the central black hole and gained almost 3 times the mass of their original size before merging with each other. And we will look at the next ability under number 8 called additional rations. Indeed, black holes can use magnetic fields to exist. One of the main factors that determine the mass of a black hole can be its magnetic field. While studying the Cygnus A galaxy, located at a distance of 600 million light-years from us, they discovered a very strong magnetic field in its galactic center. Further analysis revealed that the Swan A black hole is very active. It is believed to be the most powerful extragalactic source of radio radiation in its constellation, produced by the hole's absorption of matter surrounding it, and in this case, its magnetic field is actively involved, which attracts matter to the torus of the black hole and then to its very bowels. The difference between active galaxies like Swan A and inactive galaxies like our Milky Way is the presence and absence of a magnetic field. The ninth ability is stealth. Yes, they are second to none. They manage to hide even in tiny galaxies, for example, in the Fornax UC D3 galaxy in the constellation Pecha. There are about 100 million stars in this galaxy. It's a tiny thing compared to the Milky Way, which could possibly contain hundreds of billions of light. The Fornax galaxy has a radius of only about 300 light-years. Despite its small size, the galaxy is one of the densest galaxies in the universe. The discovery of a black hole in this galaxy was only the fourth time that supermassive black holes have been found inside supercompact galaxies. Astronomers estimate that this hole makes up 4% of the total mass of the galaxy. Generally, in all other cases, this proportion is only 0.3%. And finally, the 10th superpower. Let's call it crushing blow. In particular, a black hole can easily eat our Sun in just 2 days. Not so long ago, an amazingly voracious black hole was discovered, which originated about 12 billion years ago. The detected quasar absorbs the equivalent of one solar mass every 2 days. Because of this appetite, the black hole grows so fast that its radiation is thousands of times brighter than that of an entire galaxy. The radiation itself occurs due to the heating of the substance and the gases it absorbs. It is not clear how a black hole from the Dark Ages gained its mass so quickly, but the destructive potential is clear. If this monster were at the center of our Milky Way, it would be 10 times brighter than the full moon in the sky. The object would be so bright that it would outshine most of the stars in the sky and kill us all with its X-rays. And it's sad. Yes, black holes are really dangerous.